Hi guys, come and join me. Let's solve this question. 67 is still related to stoichiometry, so let's do it. 1 liter of air contains 0.28 grams of oxygen. If John inhales 0.50 liter of air per breath and 20 breaths per minute, how many grams of oxygen does he inhale per hour? All right, so now whenever you see this kind of question, you can all see it with me. It's like it's plenty. Yeah, so you have to break it down stepwise, okay? Try to look for relationships and then you develop conversion factors from there. All right, so let me show you how. Let us look at the relationships here. So we have 1 liter of air contains 0.28 grams of oxygen, right? That's the first thing I'll be writing. 1 liter is equivalent to 0.28 grams of oxygen. Now, John inhales 0.5 liter of air per breath. So I can write 0.50 liter is equivalent to 1 breath. Okay. Then what else can I write? And 20 breaths per minute. Okay. So 20 breaths is equivalent to 1 minute. That's how much he inhales per minute. Then what else? They said we want to know the grams that he would inhale per hour. So this is what we're looking for. Grams per hour. That's what we want to get. Okay, but then this is all we're given. So what else can we figure out? 60 minutes equals 1 hour. Okay, that's a thing. So we'll write it there. We might actually need it. Who knows? 1 hour. Good. So now we've successfully written the relationships we can get from the question and any other meaningful thing like the 60 minutes equals 1 hour. Now you've written this, we're going to use what we have to, get what we want. And we want grams per hour. So let's, start using what we have. 1 liter is equivalent to 0.28 grams of oxygen. So I'm going to write it this way. 0.28 grams of oxygen divided by 1 liter. Remember, my plan is to do all this multiplication in such a way that some of the units will cancel out and I would eventually have grams over hour. Okay, so that's the aim. So I think it's a good thing to put the grams up here and the liters down. So let's continue. We have 0.50 liter equivalent to 1 breath. So it's either I write 0.50 liter divided by 1 breath or 1 breath divided by 0.5 liters. There's only those two ways it can be. So we have to pick only one in this case. Only one will make sense. So it will make sense if I write it this way, 0.50 liters divided by 1 breath. Okay, because this would help me cancel out the liters that I don't really need in my final stuff, grams per hour. So yeah, I think this is a good call. All right, so we've used this up. We've used this. Let's see if we can use this one. 20 breaths per minute. So it would be a good idea to write 20 breaths up here, right? So I have 20 breaths here and then 1 minute. At least you know you're doing the right thing because the breath is canceling out, right? We don't even want it in our final stuff, so I think it's a good move to write it that way. It cancels out real quick. All right, so now we have minutes here, and then 60 minutes is equivalent to 1 hour, right? So we'll just use this one as well. This is minute here. We're going to have to put the minute up. So 60 minutes has to stay like this, and then 1 hour. You see how everything comes out nicely, right? Grams per hour. Now you can see it. So all you have to do is multiply all the numerator value and then multiply all your denominator value and then just solve it basically. Right? So when you do that, you'll notice that you would have it in grams per hour at the end of the day with all other units cancelled out already. So yeah, shall we multiply? So that should be 0.28 multiplied by 0.5 multiplied by 20, and then you divide it by 1 times 1 times 1, which is already 1. So you do all this and you get 168 grams of oxygen, that's O2, per hour. So that's how many grams of oxygen he inhales per hour. They could twist this question in another way and then tell you to, get something else. But all you have to do, just slot it into this format with the conversion factor. And this is called the factor limit method, by the way. It's very helpful in stoichiometry, okay? You might see something like this if you're going to study pharmacy or medicine courses in your first years. You might encounter this kind of questions, all right? So if that's you, can let me know in the comments. All right, and I'll see you guys on question 68. Subscribe if you're seeing this on YouTube because there's more that you're going to be getting. And like this video if you found this helpful. All right, so I shall see you on 68. Bye bye.